I'm going to give you guys a couple seconds. Take a look at this warm-up question. We're looking for, out of what we've covered so far, if we look at this equation here, can you tell me what the parent function is? So take a second. Think about what you see in the equation that's not a transformation and what parent function this could be. Tia? Perfect. I'm not going to call it f at x because this one's called f at x, so maybe we can call it g at x equals x squared. Okay, this is a transformation, this is a transformation, and this is a transformation. What's left is that my x is being squared. That's the main operation of the parent function. So if we removed the transformations here, that should kind of show us what the parent function actually is. Now if I saw a square root here, I would know that the parent function is root x. So just kind of looking through the equation and seeing what's the operation that this function is doing. Great. So this is going to be our last main parent function that we'll be looking at for transformations. And it is called a rational function. Rational just meaning fraction. So we did rational exponents and rational expressions in Unit 2. This is a rational function. It's 1 over x. So we graphed this one a little bit a few days ago when we did our initial introduction package, but we had some key points. We did -2 all the way to +2, but we also included half and -half. And we discussed that technically there's a 0 in between here, but we can't include 0 in our table of values for x. Why can't I put 0 in this table of values? Josh?
Make it undefined.
Makes it undefined. 1 over 0 is undefined. So when we plug each of these in here, what we're going to get is -half, -1, -2, 2, 1, and a half. These are our key points. Okay, we also talked about, because of what Josh just said, the fact that x equals 0 is actually undefined. What this causes is a vertical asymptote. And that's at the line x equals 0. So that's this line actually on the y-axis here. I'm just going to write it kind of like right next to it so we can all see it. So when I draw these graphs, I'm going to indicate these vertical asymptotes just with a dotted line, and I'm going to label them with their equations. This guy is going to shift left and right with the d-value shift. So whatever the d-value shift is, that's going to be your new vertical asymptote location. Okay, and if we think about this logically, here's my equation. If I can't sub in x equals 0 here, there's also a restriction that happens on what I can get out from this equation, or on the output or y value of this equation. There's actually no value that I can plug in for x here that's actually going to output a value of 0 for y, and that also causes a horizontal asymptote to happen at y equals 0. Okay, so we're going to indicate that here. That's actually along the x-axis. And we're going to label it with its equation, which is y equals 0. So this guy is going to shift up and down with the c value. So as the c value moves up or down, this asymptote will move that many units as well. Okay, so we've seen these functions before. We've done domain and range of these functions. So we know that these types of equations actually have two pieces to them. They almost have like two curves that are always diagonally across from one another. So when we pull out our points here, you're going to see that this set actually gives you kind of like half of the function, and then this set here gives you the other half of the function. So we need both parts of this to actually graph the whole function here. Josh?
So how do you get the, like on the table of x and f of x?
Yep.
How do you get the numbers?
So, well, these ones are just good x's to choose. You can really choose any x's as long as you don't choose 0. But for all of our parent functions, I really just chose x's that give us a good idea of what the function looked like. And then as we plug in these x's into the equation here, that's where we get the y's from. Okay, so here's our first piece of our function. Okay, make sure your graph does not cross the asymptotes. It should go close to the asymptotes, but it never crosses or touches them. And then the second half here, we have half 2, 1, 1, and 2 half. And that's going to be kind of like the reflected curve on the other side here. So again, I'm going close to the asymptotes here, but I'm never going to cross them, and I'm never going to touch them. And this is the graph of f at x equals 1 over x. You do not need to label both pieces of this equation. Both of pieces of this are represented by the equation 1 over x. So I see people sometimes they label that part and they also label this part over here. That's not really necessary. You already have the graph labeled, so you're fine. Okay? All right, so with this graph in particular, I'm not going to have you actually graph the parent function and transformed function on the same grid. What I may have you do on the test is I may give you just like 2 blank graphs, and I'll say graph 1 over x on the first graph and graph the transformed graph on the second graph. It can get very confusing when you have both sets of graphs on one, just because the function is a little bit more complex, has the asymptotes. So if anything, you'll graph these on 2 separate graphs, graph the parent, graph the transformed. So when we do our next 2 graphs here, I'm actually not going to graph this again, even though we are going to show the key points of the parent function and how they're getting transformed. Am I okay to scroll here? We're good? Okay. So this question is essentially just for us to practice combining 1 over x and our transformations. So just as a little kind of like skeleton equation, when I have a, k, d, and c here, you're going to see that a and c are on the outsides as usual. And if you guys have noticed, when we've done x squared and root x, k and d are always where the x is. So if my parent function is 1 over x, where are k and d going to be if they have to go where x is? Tia, what do you think? Yeah, basically. So 1 over kx minus d, actually. But yeah, so k and d go where x is. In this case, x is in the bottom. So k and d are going to go into the bottom. And what we can actually think of is if this a is a multiple outside, really I can simplify this to a over kx minus d plus c. That's what this is going to look like once we actually implement those a, k, d, and c changes if our parent function is 1 over x. All right, so given that information, if we take a look at part A here, here's my parent, here's my transformed, f at x and g at x. We have an a, d, and a c. Can somebody tell me what my final equation would look like here? Oscar?
Would it be 2 over, you have to put brackets, right? So it would be x,
No, you don't.
x plus 1,
Don't change it in the equation.
and minus 1,
Mm-hmm.
and then plus 1.
Great.
Why don't you change it?
You only change it when you go to calculate the transformations. So it should still look all we're really doing is just combining those two equations, so it should still look the same. Question? Okay. Yeah, so when we go to actually state the d-value, we'll state it as +1, and we'll make sure we do +1 in the actual transformation calculations. But this is still the equation, right? So we're not going to switch it in the actual equation itself. Tony? Yep. Okay, who wants to try our second one here? M?
Would it be dx equals -1 over 2 in bracket x plus 0.5 and then plus -1?
Great. Okay, here's a question. What if my parent function is 1 over x and my transformed function is something like -2 f at -3x? Actually, let's even do -1/3 x plus 2 minus 5, let's say. So there's a little bit of math that we need to do here. So what's my initial substitution look? What does this look like? Lauren? We are going to do some work with that, but what does the rest look like with the C value? Okay, so what happens based on your knowledge of rational expressions? What happens when I have a negative here and a negative here? These will actually cancel each other out, right? Negative divided by negative, that makes positive. Now, I want you to think about the graph. Why does this make sense that a horizontal reflection and then also a vertical reflection cancel each other out? If the graph looks like this. Ben, what do you think? Yeah, so if I have a horizontal reflection, this will flip over here. I'll have this piece here and this piece here. And then what's going to happen with this once I do the vertical reflection? Well, this piece will flip back down here. And this piece will flip back up here, and I'll get actually the same graph out that I had before. So that's why, algebraically and also graphically, a vertical transformation, or a vertical reflection, I should say, and horizontal reflection with this particular function actually cancel one another out. Okay. So there's one other thing that's an issue in this one, and that's that we have a fraction inside of a fraction. So when we have a fraction inside of a fraction, what we typically do is we flip and multiply that fraction. So I'm going to flip and multiply 1 over 3 to 3 over 1. And then that will actually get multiplied into the top there. So you'll get 6 over x plus 2 minus 5. So this is really the simplified version of that equation. So I would expect to see, especially if you have negative and negative for your vertical reflection and horizontal reflection, those cancel. And then if you have a fraction inside of a fraction, you need to make sure that you get rid of that by flipping and multiplying. Okay? Oscar?
What if, let's say the -2, what if it was a +2?
Then the negative stays.
And it just stays like what it is at that first.
Yep.
You know, like 2 over.
Yep. Okay. I'm just going to make this a little bit smaller so we have some room here. Okay. So we are going to graph this equation given that our parent function is 1 over x. Once we've graphed it, we're going to label it with the equation that we've come up with here. So that's our first graph. So let's start with our parent. I'm not going to graph the parent function, like I said, because it gets super confusing with both of them on the same graph, but we are going to list out at least the parent function key points with the horizontal and vertical asymptotes here. So we're going to just relist what we listed above. And if you'd like, you can actually use 0.5 for the halves here. We're going to have to eventually use decimals anyways for this one. And I usually just indicate vertical asymptote with a VA and horizontal asymptote as HA. So I'm actually going to make sure that those are included in my set of parent function key points, because those are key pieces of my transformed function as well that I'll want to make sure that I actually do the transformations to those as well. Okay, given that we have A, D, and C, can someone create our equations at the tops here for us? Sophia?
So A and C would be 2y plus 0.5.
Awesome.
And then it would just be like for D just plus x plus 1.
Great. So switch the sign of the D value. So just as a reminder, we do reciprocal of kx plus D and ay plus c. So in this case, our k value is just 1, so x will have a coefficient of 1, but we make sure we switch the sign of D in the transformation equations. Sarwa?
Are those expressions the same for like all the types of transformations?
Yep.
Wow.
Yep. So once you have it down, really the only thing that changes is the points that you start with. Okay, so we're going to take a second. We're going to take all of these and we're going to add 1 to them. So we'll get -1, we'll get 0, we will get 0.5 or a half, we will get 1.5, 2, and 3. And then we're going to take all of our y's, we're going to multiply by 2 and add 0.5. So negative half times 2 is -1 plus 0.5, that will give us -0.5. -1 times 2 plus 0.5 is going to give us -1.5. -2 times 2 is -4 plus 0.5, that gives us -3.5. 2 times 2 plus 0.5, that's 4.5. 1 times 2 plus 0.5, that's 2.5. And a half of 2 plus 0.5 is 1.5. Then we are going to indicate where our horizontal and vertical asymptotes have moved. So I told you guys what to look for on the previous page. The horizontal asymptote and vertical asymptotes shift with certain values in our equation. Ben? Yep, how did you get that? Right. So literally, your vertical asymptote will equal your D value, and your horizontal asymptote will be y equals your C value.
We switch it here to the vertical asymptote, right? It's -1 in the equation.
Yes, so, but your D value is +1, right?
Yeah.
Yeah, so that's,
It's just written -1.
right.
Yeah.
Yep. So first things first, guys, I'm going to just indicate my horizontal and vertical asymptotes with a dotted line, and I'm going to label them. So 1 and 0.5. And then we're going to plot our points. Now, if I've done this correctly, these 3 points here should form one part of the curve, and these 3 points here should form the other diagonally reflected part of this curve. And it should look relatively symmetrical, kind of like diagonally symmetrical almost. So let's graph. We'll double check, make sure that this makes sense. We have 0, -1.5, 0.5, -3.5. So that looks pretty accurate to me. Just as a self-check, if one of my points crosses over an asymptote in that set of 3, that's going to be a problem. Either I found the wrong asymptote, or I calculated the wrong point. So just be mindful of that. Those set of 3 points should not cross the asymptote, I should say. Okay, so we're going to draw our first curve there. And you should always show this kind of like approaching your asymptotes. So extend it to kind of curl around your asymptotes there. And then second half, 1.5, 4.5, 2, 2.5, and 3, 1.5. And then same thing, you should show this kind of like curling around those asymptotes. This looks pretty accurate to me because I see that none of the points make me cross over the asymptote, so that's good. And it looks relatively symmetrical. If we kind of look at these two diagonal pieces here, it looks nice and symmetrical. That's what should happen. And then I'm just going to label this with the equation that we found in part A above. And that was this equation here. So for these guys, I would expect not necessarily for the parent function to be graphed here, unless I give you a separate graph to graph the parent function. But I would also expect to see your asymptotes indicated with dotted lines and their equations labeled on here. Okay? And then I would expect to see your two pieces of your function. So that makes the whole function and the equation labeled. Okay? And then you can just show me your key points of your parent function and how you transform them. So show your equations and then calculate your new points. That's what I would expect to see. And your asymptotes too. Get rid of all this highlighting. Any questions on this one, Oscar?
Is this stuff on the assignment?
No. Question or no? Matt?
What are we doing the assignment like just after?
We're going to do it right after, yep. Okay.
Like
Pardon?
what is done in, like what we had before.
Yep. Okay.
Take a break before this
What time is your break at? Maybe we'll do the assignment right after the break.
Or what if we do decide that once we're done, we go for break and then we add to 1:30?
Ooh, I like that. That's a big win.
No, we'll start the assignment after the break. Sorry.
I'm just looking now though, this is messing with my brain, this is
Now, what if we just end last class early?
this isn't even one of
End it now?
Lots of great ideas here, guys, but no.
I think I deserve it. How about we have the assignment?
No.
right now?
Oh, you can go home, sure, but you'll get 0 on your assignment, so it's your call.
I put a vote for
I like
that.
this way. This one's the nice one. For sure.
All right, parent function, let's start with this. We're going to write out the points. If you'd like to write 0.5 and negative 0.5, that's fine as well. Make sure you write your asymptotes as well. We have a vertical asymptote at x equals 0 and horizontal asymptote at y equals 0. Rebecca?
This whole method only works if the parent function is correct?
Well, we would use these specific parent function points. The way that we set up these equations up here is the same for all of them. Yeah, but you need to change the points based on what it tells you your parent function is. So if my parent function was root x, I would use these key points instead. I mean, you should probably know what are some good x's to choose, and you can always get your y's. So you don't have to memorize the y's that go along with that. If you know the function is root x, if you know 0, 1, 4, 9, then you can just square root them and get your y's. Ben?
But any axis works, right? Like in theory, any axis works, but these points are like.
For x squared, yes. Not for root x, though. Root x is 0 and above. We can't square root a negative.
Yeah, but like if you choose like
technically yes. For some of them, if you don't choose enough points, let's say, like for x squared, if you only chose positive points for x squared, if this was your parent function, let's say, and you chose 0, 1, 2, 3, 4, you would only get half of your quadratic. So for some of them, like I'm just giving you some points that are going to give you a full idea of what the function looks like. Just to make sure that you have all pieces of the function that you need.
What points would you use for x squared?
I like to use like -2 all the way to +2. So -2, -1, 0, 1, 2. Okay? If you guys look back at your very first package that you did for me, the key points are actually right in your table of values here. So there's the key points for this one. There's the second set of key points for root x. And here's the key points for 1 over x. So if you need to refer back, they're all there for you, all in one spot there. Okay, let's finish our last one here. All right, who can set up our equations for us here? Tia.
Is it 1 over 2x minus 0.5?
Yep.
And the other one, do you want me to do the other one?
Yep.
It's y minus 4
Close.
plus 4.
Ben?
Negative y.
Yeah, there's a negative here. I know it's kind of hard to see. It's okay. Ben was really excited about that one, so. Okay, so we're going to take each of our x's and we're going to half them and subtract a half. And then we're going to take each of our y's, we're going to multiply them by -1 and subtract -1. So I'm going to give you guys a second. Grab your calculators. You're going to calculate these. I'm going to pause this and then.
I got negative 1.5, negative 1, negative 0.75, negative 0.25, 0, and 0.5.
Great.
And for y, I got negative 0.5, 0, 1, negative 3, negative 2, negative 1.5.
Perfect. Same here. Who wants to tell me what the asymptotes are? What's the vertical asymptote and what's the new horizontal asymptote? Emma.
For the vertical, x not equal negative 0.5, or it equals negative 0.5, and then y is negative 1.
Lovely. So the vertical asymptote is always just the d value, so whatever you have here. And the horizontal asymptote is always just the c value, so whatever you have with your y there. Okay, so guys, I'm going to share with you a mistake that I see all the time. First thing is, and it's always with the asymptotes, first thing is, people choose not to put this. If you put vertical asymptote negative 0.5, that is not the equation of a line. It's actually not even a point. You need the x equals and the y equals to represent a vertical line and a horizontal line. The other thing that I notice quite often is that people will switch. They'll mix up x and y here. Or when they put it on the graph, they'll do their horizontal asymptote as the vertical asymptote and vice versa. Okay? So don't be that guy that does this, right? So make sure that you actually give me the actual equation of the line, x equals and y equals. Okay, let's graph our asymptotes here. Our vertical asymptote is at negative 0.5, so that should be here. We're going to label it with its equation, so it will be x equals negative 0.5. And same thing with the horizontal asymptote at negative 1 down here. Now, if I've done this right and I've calculated my points correctly, my points shouldn't cross over the asymptotes for each of those 3-point sections. So we're going to graph our first little section here. It'll be negative 1.5, negative 0.5, which is here. Negative 1, 0, which is here. And negative 7.51, which is here. So that looks good. It does get quite close to the asymptote, but as long as it's not crossing over it, you're good to go. And then just make sure that you're curving around, that was bad. Oops. Make sure you're curving around your asymptotes here. So extend your graph to go along the asymptote. Okay, and then same thing with the next set of points. So negative 0.2, 0.25, negative 3. It's right here. 0, negative 2. And 0.5, negative 1.5 is here. So here's our graph, making sure that we don't cross or touch the asymptote. And same thing here. And then we're going to label it with that equation that we found above, which was this. I'm good? Okay, so we're going to make sure that that C value is not inside the fraction, right? It should be on the end, on the outside of the fraction. Any questions on this one? Can I clarify anything? No? Okay.